plant utilization. We talked about the bottom line, we talked about the productivity, we talked about how to convert our red ink into the blue ink. For that, you need to know that each of your baby, that is the furnace, how is it performing? Is it really the utility is 10%, 20%, 30%, 40%? So when you are keeping this track across the year, you know each your furnace has given you the performance 50%, 40%, and what that percentage was due to, whether it was down or whether it was due for calibration or some mechanical problem occurred or whatever. So what we call this as asset management. Each furnace you actually treat as an asset, and how that asset to be managed for its life cycle is what you have this information available, and you can make a better use of it. So this can actually be broken down into the utilization furnace wise. So anyway, that's expansion of the same thing. Profile. Now when you have, let's say, one single furnace, batch furnace, your programmer is going to give you the recipe. But when you have a continuous furnace, right? So you don't know how the profile is, because you are just working with the on-off controller, you are not working with the recipe. The furnace design, the length itself gives the profile. So in such environment, even the profile of the entire furnace can actually be seen at a single glance. So if you are going haywire, let's say even if you are doing some sort of a test of a product, let's say you are delivering a furnace, if you are a furnace manufacturer, and there is a FAT, the inspection is being carried out, you can actually put a sample, and then you can see if the tuning is like as he was mentioning rightly, that 10 degree chalta hai. So 10 degree ko, in order to bring it to the tolerance level, you are actually having that precursor available to you. So you know, hey, this is going little haywire. So rather than designing a furnace and then discovering the error, you are actually proactively able to find out that tolerance and then design it such that you kill that beforehand and get into the preventive mode rather than getting into the maintenance mode. Yeah. Now what happens is, let's say we talk of a pellet heating, we talk of various charge, the actual temperature and the furnace temperature. So let's say even if you talk of a big furnace, you can have 1, 2 or 3 zone depending on the way you have designed it, and the sensors are there in place, but are those sensors actually closer enough to the charge being heated? So now what you do is, we initially go into the calibration of a furnace. So eventually you will possibly put a 2 or 3 thermocouples, but then initially you possibly put some 10, 12 thermocouples to see the uniformity of a furnace, to get into the optimal design of a furnace. Now for doing that initially, like you have put those 10 thermocouples, but unless you have captured the data rightly, understood it rightly, then only you will be able to understand the location of those sensors. And for that, it is very much essential that you have the right data logging system in place beforehand at a time of designing. So that's what we can do. Yeah. Now, this is just getting into a case study. I mean, case study, when I say it is not really a case study, it is just to give you a flair that how do you make use of the instrumentation in heat treatment centric industry. Glass is a heat treatment centric industry. Let's say, for example, you can see the number of glass plants, be it float glass, blown container, ribbon tubing, glass fiber. Now you can see the amount of process, heat treatment process, which is being addressed here. So what instrumentation can do here? So fine, these are some of the various furnaces, 4R, blown glass, annealing layer, vertical integration, even right up to the packaging. There are heat treatment everywhere, including even the batch plant. Can go next. Yeah. Maybe we can spend a little time on this slide just for everybody to understand what all various instrumentation products or the devices that we are talking of. As you can see, let's say which are these layers. Now you can see the bottom various processes. Let's say batch plant, furnace, float line, annealing layer, inspection and packaging. Now this is the complete line which has got variety of heat treatment processes involved. The layer of the instrumentation, what you can see, let's say the first layer shows some of the multi-loop PID programmer controller, and that black box you can see, which is a device which is like a PLC, which has got multiple IOs. Then you can see something called T640, it's nothing but a multi-loop controller. Then you can see T800, there's some device which is like a skid mounted device. which has got a number of screens which can give you the pictorial representation of the process. This is another, let's say, the dual control network and T940. These are just don't get bothered by the number and model numbers. Those are some model numbers of Eurotherm products. Doesn't matter. Now, what am I actually showing here you is that all this, you can see a small controller there, which is a PID controller, which is like a safety controller. Then you can see a data logger. Then again you can see it. Now, maybe if you at all had any opportunity working with a larger plant, possibly you'll be able to relate to what I'm talking. Now, all these products, if they are left discreetly, you may feel that you are doing a great job by making good use of instrumentation. Here is the news. It is not so. Unless and until you know how to integrate them well, you may not be able to make a good use of it. It is like you have paid a price of good car. You possibly bought Honda Civic, but then you are not making use of it, and you are just taking only the 10% out of it. So in order to take a full blown returns out of the instrumentation investments that you make, it is required that you integrate them. And this integration, let me tell you, it is no more rocket science. There are experts sitting. You don't have to think that look, I am a metallurgist. I don't have that knowledge with me. You don't have to bother. There are people whose business is that. Give them that. I mean, do not get bothered. You are going to get all this kind of people. They are going to charge you hefty fees. It may look so on face of it, but when you consider the product cycle, the project cycle of your various asset that you are managing, let me assure you, because I have had the privilege of working on both the sites. I have manufactured furnaces myself. I have tuned the furnaces. I have dealt with the instrumentation, so I could see that that resistance of feeling that we are paying hefty money in the beginning actually gets nullified, and your return on investment is much better, and you get a peace of mind, and you get the consistency. You don't have to bother about the inaccuracies, and your bottom line is good. So these are various products. You can see the dual layer. These are the communication layer. Now, how these to be communicated, various layers like Ethernet, or whether it is a Profibus or a Modbus, don't get lost into those jargons. Don't get sucked by somebody telling you all this. Feel okay, these are various things available for us, how to make use of it. Call some experts, call guys like Eurotherm, call some PLC guys, call guys who understand this, who has a domain knowledge. See, many times what happens is, like for example, we have channel partners who have been working with this day in, day out. So they have better ability. Like for example, I am representing Invences. Maybe my interest is just to sell a product. But those channel partners' interest is to ensure that they understand the domain of where they are selling those products, and they actually can be helpful. So this complementing way of working is actually helping industry today. Next. So again, this is giving you the real-time picture. There are actually dynamics. Supposing say if the motor is running, if the valve is operating, actually it turns the color. It can actually show you the graphics of running or stopping, or the colors of let's say if it is on, it will show you green. If it is off, it will show you red. So all this graphical representation, you don't have to physically go to the furnace and see, and believe only with those gross experts fillers that itna temperature hai to itna hai. But here you are actually eliminating those gross. Not that this is going to replace your expertise. Please do not take it wrong. You do need the expertise, but at the same time, that expertise is made better use of by ensuring that there are no gross errors because of the representation of the graphical intuitive. That is, you can actually have an interactive interaction. Supposing say if you feel that okay, there is a draft there, you can see, you can actually click into there and you can get into the PID loop there. And even though you are not a PID tune expert, you are having the ability to just get into the tuning mode. The system will go through various set of PIDs. All you are doing is you can say, okay, there is a uniformity issue. Let me just get into the PID loop and play with it. So though you are not, it is like video game khelte na hum log. You are not an expert driver, but it's a stimulator, it's a simulation. You can work with it. So here, though you are not a PID tuning specialist, you can actually get into it and do the PID tuning. Hey, this is great. So these kind of things are available. What is essential is we getting present to that. It is like that initial apprehension, resistance. कंप्यूटर में अगर कुछ कंफर्टेबल नहीं लगता है तो वी फील अरे यार वो अपना बच्चे को अच्छा खेल लेते हैं, बट वी आर नॉट एबल टू डू सो, बट एक्चुअली यू सिट एंड डू इट, यू फील इट वाज इजी. So it is similarly, all this is available, you have to make good use of it. Yeah. Now, so far what I have covered is more of instrumentation, the integration and how to make good use of it. Now I am jumping to the power controls. As Mr. Arora was mentioning that we also deal with power controllers. And idea is not to sell you anything right now. Idea is to give you an idea that how these thyristor power packs actually can be used for the power management of the electrically heated furnaces. Whatever now I am talking about, it is for the electrically heated furnaces. I mean, you talk of elements like silicon carbide or molybdenum disilicide or tungsten, these are all having a different thermal characteristics, and unless and until you are doing a proper power management of it, you will actually blow off those elements, and those are expensive ones. So what we are talking here is, what is the technology today available and where are we going towards? See, many people were using only on-off controller, and then they were using only power contactor and doing the on-off, on-off, on-off. Now doing that on-off was giving a thermal shock to the heating elements, reducing the life, and giving the thermal shock to the insulation, so reducing the life of insulation as well. By making use of power controller, you are giving a gradual power control. You are